All right, let's get some practice with these product to sum formulas. In example 5, the directions say to express each product as a sum of trigonometric functions. Okay, now I want you to imagine you see these directions on a quiz or an exam. These directions are not like embedded in this particular section. How do you know what to do? Okay, well, the clue here is that this is a product to a sum. You're converting a product to a sum. So keep that in mind as you read the directions. Okay, all right. So in example A here, we have 2 times the cosine of 85 degrees times the sine of 140 degrees. Okay, yeah, you can pop this in a calculator and get a number, but that's not what's being asked of you here, okay? The directions are saying to take this product, and this is a product because it's basically something times something, okay? And you need to convert it into a sum, and when they say sum, that could also be a difference. Okay, but usually in the directions, they just use the word sum. Okay, so the answer is going to be an equivalent expression, not a number. Okay, all right, so we're going to have to refer back to our product to sum formulas to figure out which one we need to use. Okay, notice we have cosine times sine. So I'm going to flip back a page and I'm going to look at my formulas in the box. Okay, and I'm trying to match this up with one of the formulas so I know which one to use. Okay, and if I look at the left hand sides, it looks like I need to use the last equation here. Okay, cosine of A times the sine of B, we need to use that one because in our expression we have cosine times sine. All right, so I'm going to go back to my example here and I'm going to write down the identity. Okay, so we know the cosine of A times the sine of B is equal to 1/2 times the entire quantity sine of A plus B minus the sine of A minus B. All right, so what we need to do now is match up the expression we've been given to the identity. Okay, so let's find our A and our B. These are our arguments. Okay, so if you look at what we have, A is going to be 85 degrees. Okay, because in the identity, A is what you're taking the cosine of, and we are taking the cosine of 85 degrees. Okay, so I'm going to write that here. A is 85 degrees. Similarly, B is referring to what you're taking the sine of. So B is going to be 140 degrees here. Okay, so we almost have an exact match to the red identity here because we have a cosine and a cosine, and then we're multiplying by a sine and a sine. However, we have a bit of a problem because there's a 2 in front. Okay, so our expression is multiplying the cosine times sine by 2. Okay, so we're going to go ahead and make the adjustment in the identity. To get an exact match to our expression, I need to multiply the cosine sine piece by 2. But this is an equation, so whatever I do to one side, I have to do to the other. So I need to multiply the right side of the equation by 2. Okay, so what is this going to tell us? Okay, well, now we're going to have that the left side is going to be 2 cosine A sine B. That is going to equal, notice what happens. 2 times 1/2 is 1. So those guys are going to cancel out. That's going to leave you with 1. And so all that's going to remain on the right side is just going to be the sine pieces. Okay, because the 1/2 times 2 gives you 1. So we are left with sine of A plus B minus the sine of A minus B. Okay, so now this is our template that we will input into. Okay, so here we go. We can write down our answer here. We were given 2 times the cosine of 85 degrees times the sine of 140 degrees. If we convert this product to a difference, it's going to be a difference here because we're subtracting. We are going to get the sine of A, which is 85 degrees, plus B, which is 140 degrees. And we're going to subtract the sine of A, which is 85 degrees, minus B, which is 140 degrees. Okay, so that's where we are so far. Okay, we can go ahead and simplify what's in parentheses. Okay, so I'm running out of room. I'm going to come up here. Okay, I'm going to say this is equal to the sine of, I'm going to go to my calculator. I'm going to do 85 plus 140. I'm going to get 225 degrees minus the sine of, I need to do some subtraction here. Okay, so I need to do 85 minus 140. That's going to give me negative 55 degrees. And we're essentially done, okay? But I am going to clean this up a bit. Something I want to mention here, 225 degrees is on the unit circle. So we could actually write down the exact value of 225 degrees, and you can. That's not incorrect, but remember what the directions want. They want a sum or a difference, in this case difference, of trigonometric functions. So I'm going to leave it as the trigonometric function, okay? But again, it is not incorrect to go ahead and just state that exact value, okay? So I'm going to leave this guy as the sine of 225 degrees, okay, minus, but I'm subtracting the sine of a negative angle, okay? So since sine is negative, you can use, since sine is odd, I can take this negative sign and pull it out front. So it's going to come right here. So you're going to be subtracting a negative sine of positive 55 degrees. Okay. And then that negative minus a negative turns into a positive. And so the final answer here is going to be the sine of 225 degrees plus the sine of positive 55 degrees. Okay. This is the answer. Okay, so we started with a product. We started with 2 times the cosine of 85 degrees times the sine of 140 degrees, and we have converted it to a sum of trigonometric functions. Okay, sine of 225 degrees plus sine of 55 degrees. Okay, and one more time, 225 is on the unit circle. Okay, so you're not wrong by turning that sine 225 degrees into an exact value, but I am leaving it like this because I'm just adhering to the directions that I need to write the original product as a sum of trigonometric functions. So sine plus sine. Okay, let's try another one. Okay, in part B here, our product is 5 times the cosine of 3x times the cosine of 2x. Okay, same directions. I am starting with a product. I have something times something. I need to change this over to either something we're adding or something we're subtracting. Okay, we have to match it up to one of the product to sum formulas. Okay, so we need to look at the one that has cosine times cosine. Okay, so I'm going to go back to the page before. Okay, and I'm going to scan these guys to see which one I should use. Okay, and in looking at these, I need formula number 7 here because this is the one that has cosine times cosine. Okay, so I'm going to go back to my work and I'm going to jot down this particular identity. Okay, all right, so we know the cosine of A times the cosine of B is equal to 1/2 times the cosine of A plus B plus the cosine of A minus B. All right, so now we have to kind of match up our expression with this identity. Okay, so I'm going to write down what we have and try to match it to the left side. We have 5 times the cosine of 3x times the cosine of 2x. Okay, so when we look at this, I see a match with the cosines and I see a match with the other cosine. Okay, so I can figure out my arguments. I can go ahead and write those down. So the first cosine, we're taking the cosine of 3x, so that's going to be the a value. Okay, so a is going to be 3x because these guys match. Okay, and then the b value is going to be the argument of the second cosine, so that's going to be 2x because these guys match. Okay, so the only difference here, if I'm comparing uh, my expression to the left side of the identity, my expression has a 5 out front that's being multiplied. Okay, so I'm going to have to adjust the identity to my needs. Okay, to get an exact match, I need to multiply the identity by 5. If I do it to the left side, I need to do it to the right side. Okay, all right, so what this tells us now, the template we are going to use, okay, is 5 times the cosine of A times the cosine of B. That's equal to 5. You need to multiply your numbers together. I have a 5 times a 1/2. That is 5 halves, or you can convert it to 2.5 if you want. Okay, that is going to be multiplied by the entire quantity cosine of A plus B plus the cosine of A minus B. And now we can plug into it with A is 3x and B is 2x. Okay, so here we go. We were given 5 times the cosine of 3x times the cosine of 2x. So according to our little template here, this is going to equal 5 halves times the cosine of A, which is 3x, plus B, which is 2x, plus the cosine of A, which is 3x, minus B, which is 2x. Okay, so now I just need to simplify. I'm going to get 5 halves. I'm going to leave it out front. This is going to be the cosine of 5x plus the cosine of x. We're done. Okay, you can leave it like this. If you want to, you can distribute the 5 halves through. It's up to you. Okay, that's optional. It's correct either way, whether you factor out the 5 halves or you distribute it through. Okay, so I'll just go ahead and write, or you can write it this way, that this is 5 halves times the cosine of 5x plus 5 halves times the cosine of x. Okay, so I'll go ahead and box both of those. Okay, either expression is equivalent to our original expression that was given as a product. Okay, all right, let's try one more. Okay, in part C, our expression is 8 times 7, or sorry, 8 times the sine of 7x times the sine of 9x. So same thing. We have a product. We need to convert it to a sum or a difference. Okay, so we need to apply the appropriate product to sum formula. This time we're going to be looking for sine times sine. Okay, so going back to page 7, let's look at our identities, and we quickly conclude we need the first one, that is sine times sine. All right, so let's go write this down. Okay, so we know that the sine of A times the sine of B is equal to 1/2 times the entire quantity cosine of A minus B minus the cosine of A plus B. Okay, so now we need to get an exact match to our expression. I'm going to go ahead and write our expression down. We've got 8 sine of 7x times the sine of 9x. Okay, so I can match up the signs. I can match up the signs on the left and the signs on the right. And then A here is going to be 7x. And B is going to be 9x. Okay, So the only thing that's different between our expression and the left side of the identity is this 8 out front. So to get an exact match, we need to multiply the left side of the identity by 8. Okay, if we do it to the left, we have to do it to the right. Okay, so then we can adjust. We're basically adjusting the identity to our needs. Okay, so I'm going to go ahead and rewrite the identity adjusted. Okay, this will be our template for plugging in. Okay, we're going to get that 8 times the sine of A times the sine of B is equal to, simplify the numbers, 1/2 times 8 is 4. Okay, so this is going to be 4 times the entire quantity cosine of A minus B minus the cosine of A plus B. And now we will go and plug into this with A being 7x and B being 9x. Okay, so here we go. Okay, our expression is 8 times the sine of 7x times the sine of 9x. Okay, that's going to equal 4 times all of the cosine of A, which is 7x, minus B, which is 9x, minus the cosine of A, which is 7x, plus B, which is 9x. Okay, let's simplify here. Okay, this is going to equal, I'm going to leave the 4 out for now. Okay, this is going to be the cosine of negative 2x minus the cosine of 16x. Okay, now I'm left with a negative argument. You see that negative 2x, and that's where the even odd properties kick in. We know that cosine is even, so for an even function, the negative gets absorbed. Okay, so this is going to be 4 times the cosine of 2x, positive 2x, minus the cosine of 16x. Okay, we are done. Please realize you cannot combine the cosines. They are not like terms. You can combine a cosine 2x with a cosine 2x, and you can combine a cosine 16x with a cosine 16x, but you cannot combine a cosine 2x with a cosine 16x because their arguments are different. Like terms means that the arguments have to be the same. Okay? All right, you can leave it like this. Okay, you can distribute the 4 if you wish. Okay, so another correct answer would be 4 times the cosine of 2x minus 4 times the cosine of 16x. Okay, either one of these guys will work here. All right, so now we are going to move on to the sum to product identities.